day 2, introduction to proof. So just a quick warm up of the stuff you already know. So what do you know about parallel lines? Well, they never intersect. In fact, most of the stuff you can probably just do on your own. Draw 2 parallel lines. Well, how about the symbol for parallel lines? Bam. The symbol for parallel lines is 2 parallel lines. But you could also do something like this, you know. Well, hopefully straight, because those two will meet. That's horrible, but you know what I'm talking about. Are all parallel lines on the same plane? Well, yes, they are. They can be. You could also have parallel lines above each other on different planes. Okay, so they're not always on the same plane. Like if I drew a line on the floor and I drew a line right over it on the ceiling, those would be parallel to each other. But technically, you could actually say there's a plane right there connecting them, because you can always find a plane connecting 2 lines like that. So, and if you really want to get really abstract, even if you had a line 5 feet away up in the ceiling from where it is on the floor, you could draw a diagonal plane through those. So it is still doable, but that's getting kind of kooky. What do you know about skew lines? Well, we talked about that. They do not intersect, no intersect, or parallel. They cannot be parallel to each other, and they cannot intersect each other. Draw a picture of skew lines. That's kind of tough to do because you kind of need to draw 3D. Bam, 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 bam. And then just say like, oh, I want to use this line, the bottom front. And I can't use any of the ones parallel to it, so maybe this one right here, the back right. Those are skew to each other. You can pick any 2 that are not parallel and not touching. Whatever you want to do. Make it your own. Are skew lines in the same plane? No, they are not. Because if they were on the same plane, then they're either going to be parallel to each other, or eventually they will cross and touch. So that's a big no-no. Okay. Graphics here are a little messed up. Let's see if I can get this cleaned up. Okay. Linear pair, which we're looking down here below. So this is all on this area. So looking below, which pairs of angles form linear pairs? Well, 1 and 2. Okay, they form a straight line this way. It's supposed to be a straight line. Also, 2 and 3, which form a straight line right there. And then you got 3 and 4, which forms this one right there. And then I dropped the eraser. And then you also have 1 and 4, which also form a straight line. If you notice, 1 and 4 form the same one as 2 and 3. Just one's up here, 2 and 3 down here, but they still form the same straight line. And 1 and 2 form the same line that 3 and 4 do. One's above, one's below, same concept. Okay, complementary and supplementary angle pairs. Well, we kind of need to draw a right angle. Okay. It's a beautiful right angle. Put a ray somewhere in there. Okay. And then these 2 angles are not equal to each other, but they add up to 90. This is complementary. Okay, so I just realized I screwed up and missed the question, how are linear pairs related to each other? Well, they form a straight line. Okay, and they share a vertex and a ray. Okay, so they share a common vertex and they share a common ray in the middle. Okay. Now back to going out of order. Okay, so this is a complementary angles, they add up to 90. Supplementary is, like we've been doing, 2 angles that add up to 180 degrees. This is supplementary. Okay. One way I found to help myself, because I used to get these confused even years ago when I was teaching this, is C comes before S in the alphabet, and 90 comes before 180 in numbers, counting. So C, complementary, goes with 90, and S, supplementary, goes with 180. Okay, parallel lines, transversals, and angle pairs. This set goes with these right here. I'm going to try to answer both questions without forgetting. So, which pair of angles are vertical? Well, those are the opposite ones. So 2 and 4, and 1 and 3. Okay? Now, how are they related to each other? Well, they're congruent, for one thing. And not congruent. They're opposite each other. And they're formed by intersecting lines. So basically an X. And an X can be any shape. It can be thin, fat, whatever. Okay, transversals. A transversal is a line that intersects two other or coplanar lines. So on the same plane. The line that intersects two coplanar lines. Angles, not angels, angles are formed by the transversal and the two lines. These have special names, and we're going to talk about all the different types. So when you just have two intersecting lines, when you just have an X, you don't have a transversal. You have to have two lines that it's going through. So each of these lines here, these are all transversals. They're cutting through two lines. Okay? So interior angles. The interior angles are, like they sound, inside. So they're interior of the two parallel lines. They're inside. Exterior angles are, well, like they sound, outside the parallel lines. So interior is inside, exterior is outside, just like paint. Now, alternate interior, these are special ones. Alternate means, if you think about the word alternate, it means like every other one, both sides of the line. So these two are congruent to each other, and these two are congruent to each other. And if you look at them, it makes sense. The two obtuse ones are congruent, and the two acute ones are congruent. This only happens if these lines are parallel. They have to be parallel lines. If they're not parallel, this does not apply. So all these rules we're talking about here only apply to parallel lines cut by a transversal. Alternate exterior works the same way. This acute is equal congruent to that one, and this obtuse is congruent to that obtuse. Okay, so once again, just remember, only with alternate, when the lines are parallel, does this apply that the angles are congruent. So consecutive interior. Consecutive, think about what that word means. Consecutive means the next one. Okay? So when I say it, tell people is think about, wow, that just got really messed up. Try that again. If you think about an escalator, and it rides on down like this. Oh, I'm sorry, I'm thinking about corresponding. Next one, sorry. We'll come back to that. So consecutive interior means the next one. So we have 1, 2, 3, 4. 2 and 4 equal 180 degrees. 1 and plus 3 equals 180 degrees. They are supplementary. Again, only only if the lines are parallel. But if they're parallel, then 1 and 3 are supplementary, and 2 and 4. And think about it. 2 is acute, 4 is obtuse. Together they're going to make 180. 1's obtuse and 3 is acute. They're going to make 180. Now, corresponding. Corresponding is going to be one interior and one exterior. But watch what happens when I ride down the escalator, up the escalator. Okay? These two are the same. So this angle and this angle are the same. Also, if you think about a zip line, if I ride down like so, okay, those are the same. Actually, I want to make these all the same color because what happens is all of these obtuse angles, all of them, are the same. They're congruent. So 2 and 6, you ride down the escalator. 3 and 7, if you ride down the escalator, the zip line, okay, those are corresponding to each other. And those are all the obtuse angles. Now, if you think about it, inside, all the acute angles, 1 and 4, and 5 and 8 are all equal. Well, again, if you take this angle and kind of ride down, see how 1 and 5 are the same? So 1 and 5 and 4 and 8, all of our acute angles are also congruent. So when you have this situation and you know one of the angles, you can figure out all 8 angles. Okay, so we're going to look at this picture and figure out what they are. So here we have a lot more angles going on here. We got 12. And notice we have no parallel lines. So we're not talking about what's congruent. Okay, we're just going to give the names. So 4 and 5. Notice they are both in between those two lines. Okay, and they're next to each other. They're the next ones down. So they're interior and they're right next to each other in line, so they are consecutive interior. Four and 6. Well, 4 is here. I don't want to use those symbols. Well, I can. 4 is here and 6 is here. They are on opposite sides of the transversal, but both in between these two lines. So they're interior, but they're alternate interior. Okay? 2 and 8. Well, here's 2, and here's 8. Now notice, though, they are exterior of these two lines. I did not mark them congruent because the lines are not parallel. But they are on opposite sides, so they are alternate exterior. 1 and 9. See where those are. 1's here. 9 is here. They are corresponding angles. If you think about these two lines here, and forget about the middle one, and look at this transversal cutting through, this one is inside, and this one is outside, so they're corresponding. 6 and 12. Well, if you look at this line and this line, forget about the top one, and see the transversal coming through. Here's 6, here's 12, opposite sides of the transversal, so alternate. And where are they? Exterior. 5 and 11. again, looking at these two lines and the transversal, 5's on this side, 11's on this side. This is also alternate exterior. 7 and 9, where are they? They're interior of these two lines. They're on opposite sides of the transversal, so they are also alternate, but they are interior. 3 and 6, both inside these two lines on the same side of the line, so they are consecutive. Interior. 3 and 9. Between this line and this line, here's a transversal. Forget that middle line. 3 is here, 9 is here. They are interior on opposite sides of the transversal, so they are alternate interior. And then 7 and 11. Just look at these two lines. This one's inside, this one is outside, corresponding. Okay, name the transversal connecting each pair of angles, then classify the relationship between the angles. So we're going to make a chart here. We have our transversal and our relationship. 4 and 10. Wow, there's a lot going on here. So here's 10. Here's 4. Well, the transversal is transversal A. One's on the left top, one's on the bottom, one's on the left, one's on the right, whatever you want to call it. And notice they're outside the lines, so they're alternate exterior. 7 and 3. 7 and 3. Here's 7, here's 3. They're on D. One's inside, one's outside, so they are corresponding. 8 and 14. Here's 8. Here's 14. They are on C. Well, they're in between the two lines, okay, and they're the next one down from each other, so they are consecutive interior. Four, 2 and 12. Here's 2, here's 12. Here's the transversal. We're back at A again. Okay, they are on opposite sides of the line, but they are between these two lines, so they are alternate interior. 13 and 10. Here's 13. Here's 10. They are on transversal C. One's on this side, one's on that side, which means they're alternate. And compared to these two lines, they are, actually they're just alternate because 10 is exterior and 13 is interior, so they're just alternate. That's kind of a mix-up, I think. And number 6, 6 and 14, here's 14, here's 6, transversal C also. Okay, so this one also is alternate, but we're going to say none for both of these because there's actually no property, but you should at least recognize they're on either side of the line, but that's the only important thing. And there you go.